The next QPU operation, we have seen one QPU operation. Okay, so we have seen that first QPU operation is which gate? Not gate. Okay, now we will see the Hadamard gate, right? What Hadamard gate is going to do? It is represented as in short as a HAD, okay, based upon the first 3 letter. So when you apply Hadamard gate to a qubit, so it creates an equal superposition to both the state. For example, you can see here, this is my qubit, right? Either qubit will be represented in this form or qubit will be represented in this form, right? Here 0 is filled, here 1 is filled. Then when you apply Hadamard gate, what will happen? It will take the same magnitude, either you apply to this configuration or you apply to this configuration. The only thing is that in order to distinguish these two, the relative phase is shown opposite here. You can see both are filled with same thing. So magnitude wise there is no difference. So when you apply Hadamard gate, both wise you can see both case, whether it will be 0, I am setting the 0 or I am setting the 1, all cases the magnitude is same, but relative phase is changed in the case of 1, only to distinguish that whether you applied 0 or you applied 1 into the Hadamard gate. But in terms of this field area, it is same. So now the question arises that if Hadamard gate is applied and if I am applying another Hadamard gate, then whether I am getting the same thing or not. Okay. So Hadamard gate operation is its own inverse, right? If you have a gate like this, if you apply Hadamard, again you are applying Hadamard, then you will get the same value only. Okay, applying multiple times Hadamard gate, you will get the same thing only. So that's why it is having its own inverse. Okay, the next one is read. So I told you, once you have done a couple of operations using a quantum computer, at the end you are going to read the bit, and for reading the bit we are representing this one, and in some diagram you will find there is a value 0 here or a value 1 here. Okay, but both are considered as the read operations, right? So read is a unique in being only the part of the QPU instruction set that potentially return a random result. Okay, based upon the superposition it is going to generate you the result. Now this symbol is considered as write. Whenever you are initializing a qubit, then you will use this particular symbol before you operate it, right? So it is a deterministic process. The next one is that how to perform the read and write operation. I told you read operation will give you the value either 0 or 1. So assume that you are present in this state with 50% to the 0th notation and 50% to the 1 notation. So when you apply read, either you will get this state or you will get this state. There is no other state. Similarly, somebody can say that I have 85.4% probability of this state, 14.6% of the probability of other state. Still, if you apply read, finally it will give you either 0 or it will give you 1. So this is treated as 0 and this is treated as 1, right? So applying read to any single qubit will return you the value 0 or 1, with the probability determined by the square of the associated magnitude in the qubit, ignoring the relative phase. We are not changing the relative phase. Whatever relative phase is there, we reset to the initial phase only. We are not going to consider any relative phase when we go for the read operation. Okay. Similarly, if you want to perform write, so write can also be done, because sometimes we have seen like we say some gates are called as universal gate in conventional logic. Which gate is called as universal gate? NOR and NAND and NOR. Why we are saying it is a universal gate? We can build this any other gate using these two. In the similar fashion, here you can see, I can take a read as a gate, NOT is a gate, and we can construct the write as well. Okay, combination of read and NOT will give you what? Write. That also you can do. So you can mix one or more gates, and you can form any other gate also. But whether it is a read operation or a write operation, it is not reversible. You cannot reverse it. That means 2 times reading same thing, it will not reverse the original thing. 2 times write the same thing, it is not going to reverse anything. But the previous operators which we have seen, Hadamard gate case we have seen, it is having own inverse. NOT case also we have seen, it is having its own inverse, right? But this case it is not at all true. So let us start with one program. Suppose I will ask you write a program to generate a random number. You know random number, suppose I will ask you to generate a random number in between 0 to 10. Right? So somebody will say that random number is 5, somebody will say random number is 7. But generating this random number, behind this random number there is a algorithm running. Random number is also not random. It is based upon the algorithm, right? So in quantum computing, we have something called as pseudo random number generator. In short, we call that as PRNG. So PRNG is popularly used in the cryptography. Even if recently there is a CCMT counseling, that is Central Counseling for MTech admission, or MSc admission is conducted by NIT Warangal. So I was involved with the counseling process, because when you go for the counseling process, you will find many people are having the same mark. If you conduct a all India level test, let's say 10 lakh people, 10 lakh candidates are appearing. So you will find many students are having the same mark. So how to resolve this problem? Suppose assume that these 4 are secured same mark in the same exam. I cannot assign the same rank to all 4. In what way I am going to resolve the problem? Any guess? First one, what we are looking is the age. Okay, means whoever is elder given more priority, not younger. Okay, elder is given priority. Assume that 4 of them having same date of birth. It is not likely condition, but we have seen that some cases there is also a tie. Then who will get the first rank? No, mark is same. Mark is same. It is a, like all India.
Previous degree mark should be considered.
But previous degree mark is not there in the database. That is true. Whatever you are saying, that is also a criteria. Date of birth is done, na?
Category wise.
No, category wise it is not considered. One by one, sir.
Maths, physics, chemistry,
हाँ.
subject wise. So which subject has
Sir is saying math, physics, chemistry. So suppose I will take math is more priority compared to physics, chemistry. That way you can resolve the problem. But in GATE exam, which happens after BTech, these are not considered. GATE is only based on computer science or physics, mathematics, like that. So there is a way to solve this one. Madam, what you told? What is the way to solve this problem? Date of birth, first we have taken. Let's say date of birth of 4. Which priority? Where you will decide the priority?
social status?
Huh?
Social.
No. It is not.
Random pickup.
No, first means those who filled the first application form.
No sir, randomly pick up the.
Yes, that only I am discussing. Predefined criteria is that if say everybody gets same marks, let's say gate score is 500
Time management.
for everyone.
Randomly pick up.
Time management, duration. No, that our system is not that much clever. That is good way, but that is not a clever, that much clever.
Randomly select one.
And so there we generate this one, PRNG. Okay. So first, if the four of them are secured the same score in gate, so first we will check the date of birth. If date of birth resolve the problem is solved. If date of birth not resolve the problem, we generate a unique pseudo random number generator for each and every candidate. For example, 60,000 people appeared a national level test, then 60,000 random number is generated, not 1, 2, 3. It is randomly 60,000 is generated, it is put in one column. So we will check the random number of these 4 people. Based upon that number, whoever having lower number, that will be decided. That is the criteria followed in all India level. Whether we know or not, that is different thing. Although many people got the same mark, but their rank is different, right? So this pseudo random number is not only used in the examination system. You go for cryptography, or OTP is also an example of this pseudo random number, right? Because of OTP, we are safe in many cases, right? Now the biggest challenge is that remembering the passwords. If you are using 10 websites, right, you have 10 passwords, right, and every 3 months they are changing, asking you to change the passwords. So you forget that which site, which password you have given. Finally you donate your password to Google. Okay, when you choose Google, then automatically it fills the password, right? So that is also a challenging part when we look into this number. So whether it is a cryptography system, or it is a weather forecasting, or any disease, all these cases when there is a conflict, then we use the pseudo random number to solve this particular problem. So pseudo random number also can be generated.
Unique numbers,
Sir?
pseudo random or unique numbers.
Unique numbers. Okay. For a particular time instance, it is unique. For example, you got a OTP now. I will not get a OTP with the same number for that particular period of time. Maybe after 1 second I am also getting the ATP which is same as your OTP, but as it is not irreversible, so it is not possible to identify which transactions, right? So that's why nowadays also I am thinking that can we propose a solution where we can avoid this kind of password facility. I don't want to remember all these passwords, it is very difficult, right? So is there any methodology we can use? OTP is always a best authority. When you log in into a portal, it will ask you OTP. If you give OTP, then you are authenticated, no password is required. And most of the sites also integrated like this only, right? Because remembering is very difficult. But as I said that these random numbers always follow a mathematical distribution. You studied uniform distribution, normal distribution, exponential distribution, different distribution I have studied. All these distribution plays a role for generating the number. Don't think that if I generate 10 numbers in between 0 to 10, you will get all numbers are same. It is never occur, because the algorithm is designed in such a manner that you will not get the same number, right? So it follows a particular distribution. But if you have idea about this pseudo random number algorithm, how this algorithm actually works to generate a random number, it also contain one component that is called as computer memory. What is the state of computer memory? That also takes a important role when we generate a random number. So with a stable configuration, if I tell you what is my computer memory, what is the state of my computer memory, and if I tell you what is the pseudo random number algorithm, then you will be able to guess what is the random number. You will be able to guess it if two things is known to you. The algorithm you understand very carefully. Second one is you know the status of your computer memory. With these two, it is possible to crack that particular number, right? So, but the number is so huge, right? The number, if you take a large range, it is so huge. So within a particular time duration, if it is not identified, that is of no use. Like somebody got your OTP, let's say after 2 hours. That is of no use. At that time the transaction is either declined or the transaction is successful. Like if you take an example of a ATM counter also, when you insert your card, if you give 2-3 times wrong pin, then your pin is blocked. First is pin is blocked, then if you go for multiple attempt, your card is blocked, right? That way that particular problem is solved. Otherwise somebody can type na 0000 0001 up to 9999. Definitely your pin is in between these only, right? So multiple attempts, that's why that is not made. That's why when you look into a constraint of the time, when you apply such algorithm for generating the random number, it is unpredictable. Okay, but it is possible if you know the algorithm and memory, you can find the position, but how faster you can find that one, that is more important. If you find after 2-3 hours, that is of no use. Within a fraction of second, if I generate, then I can misuse it or I can identify it, right? Otherwise, it is not possible. So, see here, in our gate, I already told you this gate is called as which gate? Circle right gate. Okay, so I have taken a qubit, right? Then I apply write. Okay, write will write a particular bit, either 0 or it is 1. Then I am going to apply the Hadamard gate. After Hadamard gate is applied, it will be in the superposition state. Then finally I am reading. So in order to identify, as I am dealing with one qubit, it is easy to identify. But sometimes we deal with multiple qubits. Okay, like here I have mentioned qubit 1. Suppose I will go for multiple qubits. Okay, let us say this is my qubit. Okay, this is qubit 1. Let us say I am going for another qubit 2. I am going for, let us say, another qubit, let us say 3, another qubit, let us say 4. So when you are dealing with multiple qubit, you can apply different operation to different qubit, right? For example, here I am writing, right? Here I am applying, let us say, Hadamard gate in this case. For example, in this case also I am writing here and applying Hadamard gate here. So how to know that which operation is applied to which qubit first? For knowing that, there is a vertical line. You can see there is a vertical line, right? So what this line indicates? This line indicates that which operation should follow which one. And you will not find any difference with a single qubit. As it is a single qubit, you all say that I am doing the write operation here, then Hadamard operation here, then read operation. But it may happen that I will take another qubit where Hadamard operation I will apply here. If it is present here, it indicates that I am operating qubit 2 first compared to qubit 1. If a Hadamard gate is present here, then after this Hadamard gate is applied. So for that we are using this vertical line. So when there is a sequence of operations and when we are dealing with multiple qubits, in that case a line is used for moving from left to right, that indicates that which sequence of operation I need to carry out for which particular qubit. Okay. Now let us start the first program, right? So all of you go to this website. Okay, already these programs are written, just I will tell you the highlight about these programs. So I will open in Google Chrome. All of you open this one. Wi-Fi is there? Then you can. I connected through my mobile. So if you please connect to Wi-Fi, that is much faster. Please. So please open and try to practice the basic gates using these codes, so that you will be idea about fundamental part of quantum. Then you apply in your respective domain, right? Like I am more focused on how to run multiple assignments or multiple tasks in different machines, which is required for scheduling of different tasks in machines, which is used in the cloud. That's why I want to develop some algorithm which can helpful for me for applying different scheduling algorithm in a distributed environment. So first we need to understand these codes. Yeah, connected. Huh. Okay, see here I am removing these command lines because command line has no meaning, right? Right, so see here the first statement which I have written is QC reset 1. QC reset 1. Why it is not coming? Okay, is it visible now? QC reset 1. What it indicates? It assigns 1 qubit for this particular program. So if you want to allocate multiple qubit, what you will write? 2. If you need 2 qubit, you write QC QC reset. Reset is used to initialize a particular qubit. So QC reset if I write 8, so I am initializing 8 qubits. So like that, when you go for a quantum computer, like I showed you some quantum computer with 1100 something qubits, you cannot exceed this parameter value beyond that particular value, right? It is not possible to expand. In actual computer, suppose my quantum computer satisfy only 10 qubits, so this value will range from 1 to 10, it will not exceed 10, okay, because it cannot hold more than 10. So in order to allocate any bit, you will write QC reset, within bracket you will mention 1. Okay, so I am removing rest of the part. I am removing rest of the part, just I want to run this program. When you run this program, what you are getting? You check in the right side, I told you there are 3 windows. One window for circuit, another window for, you run line by line so that you can understand. So I am creating a qubit. Qubit is always represented as, see, qubit is always represented as 0x1. 0x1. What is x1? This is 0x1, just like hexadecimal representation. Hexadecimal representation we are using x. So 0x1. So when I go for the next qubit, it will show 0x2. Like that it will go on. So program circuit case, you can see I am initializing 1 qubit by allocating a qubit. Now if you come down to know that what is there in the circular notation. In the circular notation, what you have? It is filled, 0 is filled, right? Relative phase is at 12 o'clock, right? And 1 is blank, right? And there is no output. Normally the meaning of output is that when we display a particular message, like we write hello world program, right? In hello world program, we want to display a particular message. So in these cases, we normally not display. So there is nothing is shown in the output screen. Output is the third one. If you go down, you will find, okay, blank output, right? So have you understood the first line? So based upon the number of qubit, you will give this parameter. If you give QC bit 2, it will create 2 bit. If you write QC bit 4, QC reset 4, it will create 4 bit. Now I am writing the second line. What is my second line? QC write 0. So after writing QC write 0, you can see what is changed in the circuit. As this one is write, which gate is used for write? So this is representing write, a circle followed by a Y mark, okay, is considered as a write. So in circuit now it is changed. This represent the first line, this represent the second line. Now go to circle notation. You check what is there in the circle notation. It is showing 0 is filled, right? Now 1 is blank. Now simply you change. It says that write the value. It says that write the value 0. I don't want to write the value 0. I want to write the value 1. Okay. So when I run this code, what I am getting here? I am getting here, you can see instead of this circle and y, it is 1 now, because I am operating the first notation, I am not operating the 0, right. So, you see that notation change. By looking into notation, you will know whether you are operating with 0 bracket notation or first bracket notation. Similarly, you come down, see the circle, you will find that in the circle 1 is filled, 0 is blank. So, now you understand that I can write a 0 bit, I can write a 1 bit based upon the requirement. Is it clear? I have changed it to 1. So, by default it is 0, in that code it is 0, but I changed to 1. So, when you are changing 0 to 1, what is the circle notation change, what is the circuit change, that you can see here. Okay. Now, coming to the third line. Third line is to apply Hadamard gate. So, I am again pasting the line and I am removing the last line. Okay, QC head. So, it is applying Hadamard gate, right. H is added after the right operation, as it is 1, it is 1. If you are having 0, then you will find a 0 here. Then you apply the Hadamard gate. So, see the difference between Hadamard gate when the right is applied to 0 and the right is applied to 1. Just check it once. If you apply right to 0, then followed by Hadamard gate, right, which is nothing but I am applying right operation, then Hadamard gate, or I am applying 1, then I am applying Hadamard gate. What is the difference in terms of circle notation? See here, I am doing here. Okay, let us see. So, when I run this program, what I am getting? In terms of magnitude, is there any change? No, only phase wise it is changed, right. So, simply I will change here 0, I will go 0. If I run this code, so you can see here 0 is coming. So, magnitude wise you are not getting any difference, only phase wise it is getting difference when you apply the Hadamard gate to 0th notation or the first iteration, okay, or direct notation, right. That is only going to be changed. Now, once you represent in Hadamard gate, right, we are going to read it. So, for reading it, we are writing the next line, which says that I am declaring a variable, the variable name is result. You can mention any variable name. Okay, var is just like a variable, I am giving the name is result. Okay, so in order to read a something, you will write qc dot read. All are qc dot something, right? qc dot read. So when I go to qc read and run this code, see the circuit change. What will be added here? A AND gate type symbol will be added. So AND gate symbol, but it is representing what? 1. So if I see the output, it is showing 1, which is originally you also taken 1, now also you got 1. Otherwise, you can also see here, right, if I take this right value as let us say 1 and run this code, then what you are getting? You are getting 0. So try to practice this thing, these 4 things. Sir?
Can't we modify here, sir?
You can modify, na?
Sir, here
You change.
is an object.
It is reset, sir. It is just like a object only. You see dot. Where is your dot? Oh, it is jumping. You can able to modify. I am also using the same thing, but I think keyboard something is changed. That's why it is taking space. Is it clear? These 4 lines of code. Yeah. Quantum?
Programming is also object-oriented programming because we are using objects.
Type of object only. See, all higher languages are a part of object-oriented programming only. That's why QC.
We are already using Python here. We didn't use any.
Python. What sir is mentioned, Python also there are so many packages are there through which also you can run.
Sir, here we didn't use print.
No, we have not used print statement. If you write some print statement, I'll tell you. Print statement, if you explicitly mention, then only in the output screen it will be displayed. And it is same as it is the work of CPU. It is not the work
what
of.
is happening inside, it is showing.
Okay. Is it clear what these four statements? One is the reset, then first we have applied reset, then write, then ADAMAT gate, then the last one is read. This way you can write a gate and you know what is the circuit indicates, and also you have seen what is the circle notation equivalent, right? Now you tell me how to design this circuit. Okay, if you cannot design this circuit, tell me what is new in this circuit. Okay, so if I take this part, okay, how many things are there here? 1, 2, 3, 4, 5, 6, 7, 8. So I can take 8, total is 8. 0 to 7 or it is total is 8, right? So I am applying write operation on each and every qubit, right? Then I am applying ADAMAT gate, okay? Then I am reading it. So either it will return 1 or 0 based upon the state. But it is not only can be done with multiple qubits, right? Sometimes a state may be present in multiple cases, like superposition we say, right? Superposition means there are multiple cases. In each and every case also you can apply different operations. That's why you can see one single random qubit program we apply parallel program 8 times.
So the reset 8, sir?
Reset 8 will create 8 qubits. You check this one. If you change to 8 bit, okay, if I am checking 8, then it is getting 8 qubits, right? So which I have already mentioned you, 0x1, 0x2, 0x4, okay, 0x8, 0x10, 20, 40, 80, some numbers it is given, right, not 2 to the power something, right? And in some case I am writing 1, some case I am writing 0. For example, in this case you can see, this case I am writing 0 or 1? 1. Rest of the case I am writing 0. Then I am applying ADAMAT gate, then I am either reading a 0 or a reading I am 1, right? But this is not the actual use of multiple qubit, because this task can be done sequential way as well, right? There are 8 things, just like if you know the difference between a synchronous way and asynchronous way. What do you mean by synchronous way? Suppose I have 8 bit of information. I have 8 bit of information in the sender side. I want to send that 8 bit of information in the destination side. Okay. If it is synchronous way, when you change a bit in the sender side, it will be immediately reflecting in the receiver side. A practical application is Google Drive. I have Google Drive in my laptop, I have Google Drive in my mobile also. Whenever I am changing a bit, if internet connection is there, simultaneously is syncing to my device also. So instead of going for synchronous way, if you go for synchronous way, you will use multiple qubit. But asynchronous way also you can do. I will take the first circuit, then second circuit, then third circuit, like that I will take 8 circuit. So asynchronous way also I can do it. You change it to 8, madam. These are random bits. Random bits. These are random bits. So all of you do one thing. Okay, you take only 2 qubit. So all of you take 2 qubit only.
You see one dot.
Okay, all of you take 2 qubit and see the circle notation. What you are getting? So if you are taking 2 qubit, you will get 2 to the power 2 number of circle notations, right? 2 to the power 2. So I am getting 4. So one is 0, another is 1, another is 2, another is 3. Okay. Similarly, when I change this QC reset to 3, okay, so it is adding one more gate, then number of possibilities I am getting here is okay, you are getting up to 8. 0 to 7 is 8, right? So you are getting 8. Okay. So now you habituated with the simple thing which I mentioned here. I can go for parallel way 8 times. Okay, simultaneously I can make use of multiple qubit, or I can use these 8 qubits one after another, so that one qubit also can perform the thing. It is a simple pipelining process which we have studied in computer organization architecture. Pipelining concept, right? So if you have 4 different pipes, right? So you can do 4 operations at the same time. But if I reduce to 2, then 2 operations you will do, rest 2 operations you will do once it is completed. The same process is also applicable to here. Okay, so what I have done here, to change this code, write like this: QC dot reset 8, QC dot write 0, QC dot hadamat get, where variable result is equal to QC dot read, QC dot print is equal to result, QC dot print result. What you are getting here? 117. What is 117, sir? Output you are getting. Okay. What value you are getting in output? Huh? 24. You will get different because you have used hadamat gate, right? So superposition is different in every case. So that's why the output value will vary. 1 lakh?
Not 1 lakh, sir. 1 crore 64 lakhs.
When you run again.
Yes, sir. Same thing. If I run again,
it will come random, no? Because of the
then
superposition.
again it will changes. Now it's nearly
Because of superposition, because of superposition, the value which is shown in the output is going to be changed.
the starting value is common, sir. 164 again 164 added value. 164 again added value.
164 it is adding in each and every value.
First time I got 164, sir.
Okay, next.
Second time 164, again some other numbers. Third time again 164, added some numbers.
Okay. Some random value we will get, right? It is not, we cannot trace that one. No, it will show all the circuit 2 to the power something, na? It is not showing 2 to the power something circles. 2 to the power 8 you will get. 2 to the power 8 number of circles you will get. You scroll it. It is not displayed because of the screen. See, if you are taking n number of qubits, number of circle is 2 to the power n. That is we have seen in binary system also. Same thing will be affected here. Okay. Yes. Then we have seen this phase. Let us try to integrate phase into this particular program. What actually phase do? Phase is not there in the conventional system or binary system. Phase is not available in the conventional system. It is a new thing in the quantum. So all of you know that when we apply this instruction actually manipulate the relative phase, right? Relative phase is nothing but the dark line. So it is changing that phase of a qubit, changing it by some specified angle. For example, here if you see I am writing phase, the angle is 45. So what it will do? It will do 45-degree rotation. Previous example I showed you with only one, that's why you are not able to distinguish. Here you will distinguish it properly. For example, after Hadamard gate the situation will like this one. All of you agree or not? If I am taking writing 0 bit, writing 0, not writing 1, writing 0, then I am applying Hadamard gate, the situation will look like this one. Relative phase will be like this, and equally it is 50% probability, 50% probability. Now if I apply 45-degree phase, so what will happen? It will change the rotation of which one? The one circle. It is not going to change the 0 circle. So in circle notation, the effect of phase theta is to simply rotate the circle associated with 1, state of 1, right? So it will change it to 45. Can you write this code? Write down this code. What is the code you will write? QC dot phase, QC dot phase. Within bracket you have to supply the parameter degree. So in this case I am taking 45 degree, somebody can take 90, somebody can take 180. So write down the code. After Hadamard gate only you have to do, because you see our input is a Hadamard gate. After Hadamard gate only we are going to apply this operation. So this is the code. I am taking 1 qubit, so I am writing QC dot reset 1, then QC dot write, that is 0, okay. Then QC dot head is Hadamard gate, QC dot phase, within that you write the value. It may have multiple parameter, but these parameters are optional parameter. So I am mentioning, let's say phase is 90 degree. Then you read the bit. Don't write other codes. Other codes are dependent on other concepts. Up to QC phase you write. So let me show you here. So I am taking 1 qubit only, writing 0. QC dot phase, let's say 90. Okay, let me remove this part. Okay, let us see, because we know up to this one. So if I run this code, you can see after Hadamard gate there is a phase symbol and it is displaying 90 degree, right? That is added into our circuit. So we will see what it is showing in circle notation. In circle notation you can see it is not affecting our 0. Is it affecting 0? No, but it is affecting 1 by 90 degree. You try to change 90 to 180 degree. Minus you have to use. That I will come to that. Yeah, one is anti-clockwise, another is clockwise. Positive is clockwise, anti-clockwise. Negative is clockwise. So 90 degree and minus 90 degree same state only, right? So if I change it to 180 degree, I am getting like this. Which case you are getting like this symbol? No, which case you are getting this one? No, this is phase wise you are getting the circle notation, but before this also you have seen this symbol. Before this also you have seen symbol. Where you have used? Not get. No, not get is not changing the relative phase, right? No, relative phase is changed, that is true. I am saying that previously also you have seen the circle notation. Where you have seen? Okay, let me show you. Then you will remember. Why I am showing you? Because these two gates are equivalent. So while writing the superposition is there. Superposition wise, whether you write the same relative phase or different, you will get the same thing. Okay, see here. Which case you have? When you have written right value is 1. No, not that 2 hadamet. When instead of writing 0 bit, you are writing bit 1. You write na QC write 0. If I write QC write 1, after that I am applying hadamet gate. Then what I am getting? It changes the relative phase, right? So the same thing can also be implemented by taking a hadamet gate and changing the phase to how much degree? 180 degree. Okay. So doing a operation with 1 is same as doing a operation with 0 with a phase of 180 degree. Both are equivalent. Just like in digital logic also we see, right? Suppose you are designing a digital circuit, there are many ways you can design the digital circuit. In the similar way, these two are equivalent to each other. Okay. Okay, what about reversibility? It is reversible, right? Because I told you if I am doing 45 degree, then I can apply minus 45 degree. So it is anti-clockwise, it is clockwise. So they are reverse of each other. Applying phase 45 degree and applying phase minus 45 degree, both are same, right? That's why phase operation may be reversed by applying phase with the negative of the original angle. So that will give you the original one. So there are some extension of phase. Okay, there are some extension of phase also. Like in this case also we used hadamet gate followed by the phase. So using this hadamet gate and phase, we can produce some single qubit quantum states which are represented as like this, plus, okay, plus, you can go for minus, then let us say plus y, and you can go for minus y. These 4 operations you can also apply. These are the thing, nothing but different variants of our phase operation, right? For example, you can see here, right? There is a plus. Plus means you can see their magnitude is same, relative phase is also same. This case, if it is relative phase is pointing to 12, let us say in wall clock, then it is pointing to 6. Plus y is nothing but it is 90 degree phase, okay. Minus y means another 90 degree phase in different directions. One is in anti-clockwise, minus is always clockwise. That's why I told you anti-clockwise always minus, always plus. Positive means anti-clockwise, negative means clockwise. So this way also we can go for 4 very commonly used single qubit, which are the variants of the phase. Okay. There is another one. Instead of going for this phase, we can go for ROT, ROTX, ROTY. So you note down these two. ROTX means, what is ROTX? The x-axis rotation by 45. or y axis rotation by 45. Okay. So these gates are also you can use. Only thing is that instead of writing phase, I can write ROTX, ROTXY, ROTY, and the parameter that I will take is theta. Theta is nothing but the angle. The angle which I have taken here is 45. So you can see in the first case, I am changing it by 45 degree. So when you apply rotate x is represented as Rx, rotate y is represented as Ry. So check this one whether magnitude is changed or relative phase is changed. That's why I told you all these gates you make a table and indicate that if you apply a particular gate, magnitude is changed or relative phase is changed or both are changed, that you make, then you will be habituated with all these gates. So in this case you can see when you apply Rx, nothing is happening to 0. But in the one case what happened? Somebody also asked, right? Somebody also asked before break, right? You asked about the magnitude and the relative phase. You can see here, not only magnitude is affected, but also phase is there. But remember that if I am changing the magnitude, right? Somebody is having 0% probability, another person is having 100% probability. So I am increasing this person probability from 0 to let's say 10%. So this 100% probability will decrease to 90% because probability will never exceed 1, right? So you can see, although it is not distinguishable, right, but you can see there is a small gap here. Okay, it is not a filled circle. This one is not a filled circle. Some space is left out, that is carried out here. Okay. Similarly, if I am applying right 1, instead this is right 0, this is right 1, then this will be as it is. This will be as it is. Which one is changed? 0 is going to be changed. 0 will get what? Magnitude, as well as 0 will get some phase. Right? That way we can do it. Okay. Similarly, RY case also, you will change the magnitude, you will change this one. So note that always it is not possible to represent in the circle notation. Circle notation we can present because it is a two-dimensional space. Normally in quantum computing we use block sphere representation. Okay, block sphere representation is used, but it is a little bit complex notation compared to circle. That's why we follow the circle notation to perform the thing, right? Otherwise this is an alternate way of representing block notations we can use to represent a circuit. Now can we say a NOT gate is same as Hadamard gate followed by phase of 180 degree followed by Hadamard gate? Check it once. You write the code for this one. Okay, suppose I don't want to, because see, applying these gates is each gate has some cost, right? For example, you know addition is much better than multiplication. Multiplication is a costlier operation. Division is much more costlier than the subtraction, right or not? So sometimes NOT I don't want to use. If I don't use NOT, as an alternative what I can do? Hadamard gate, 180 degree, another Hadamard gate. So simply what you can do here, so you see here I am writing 1 qubit, then QC right, Hadamard gate, then once Hadamard gate is there, suppose I am writing one more time Hadamard gate. So what will be the output? So 2 Hadamard gate is added, right? This is your qubit, this is your right operation, there is a Hadamard gate, another Hadamard gate. So circle notation what you are getting? What you are getting? Same only, because I told you Hadamard followed by another Hadamard is cancelled to each other. Like we say na, one value followed by its inverse is equal to the same value, right? So when you apply 2 times Hadamard gate, it is cancelled out. Now what this says, this says that in between these Hadamard gates, in between these Hadamard gates, what I want to use? QC phase of 180 degree. So if I go for QC phase of 180 degree, let me write here QC phase of 180 degree. See the changes. Okay, forget about it. You remove this one, otherwise you will not able to distinguish. So when I run this code, now I added a 180 degree phase, right? So when I look into this 180 degree phase, you can see it is opposite, right? It is just like what? I am applying Hadamet gate to 1. When you write 1 and applying Hadamet gate, then you apply again QC head. So what it is showing? Is it changing just like a NOT gate? So NOT gate equivalent is what? Applying Hadamet gate, phase of 180 degree, again applying Hadamet gate. Okay. Similarly, you see the second operation, either they are equivalent or not equivalent. What it shows? 180 degree phase is same as applying Hadamet gate, then NOT, then Hadamet gate. Can you write a code for this one? How we will write for NOT gate? What we are writing for NOT gate? QC dot NOT. QC dot NOT. One program you write and with QC dot phase 180. Another you dot with QC dot Hadamet gate. QC dot phase of 180. Again QC dot phase. Then you see that both circuits are same or not. Okay, let me show you here. Can I take these chairs? No. Okay, see here. I have taken one qubit. I am removing this part. Okay. What I am saying? Phase angle I have to take, right? QC dot phase 180. So if I run this code. Okay, now instead of writing this QC phase, let me comment this, and what I will write? QC dot Hadamet gate, QC dot NOT, then QC dot Hadamet gate. I think without semicolon also it will work. Now semicolon has no value after Python. Semicolon has no value, right? And bracket is also not sometimes no value. If you write, it is optional, right? Okay, if you are following, that is good only. So I am getting what? The same one. So they are treated as equivalent. Okay, there are some few gates because we have less time. I will complete the one qubit part. So this is called as root of NOT. Root of NOT. R naught. In short, we call that R naught. Okay, root of naught, right? So when you apply 2 times root, you can see this equivalent indicates what? When you apply 2 times this R naught, what you will get? You will get NOT gate, right? Another way also you can do, if I want to perform R naught, it is equivalent to performing a Hadamet operation, then phase of 90 degree, then again Hadamet. That will also give you the root. So do this one. So what should I write here in code? QC dot R naught. So check. QC dot R naught you check what is the output you are getting. Then you try with QC dot Hadam at gate, QC dot phase of 90, again QC dot Hadam at gate, whether they are same or not you check. R naught? R naught, R naught. Huh.
So maybe the R is R.
Small only, all letters are small, right?
So that I'm not getting so. See sir, here are just, that's it.
Run it. Is it running or not?
QC R naught is not a function.
Okay, okay.
That's why I also have already.
Okay, I'll tell you the syntax. Just we'll go back to QC dot root naught, not R naught. Okay, root naught. You write root naught. ROOT then naught. ROOT naught, not R naught. QC dot root, ROOT root, not root naught is a one word, not R naught. Okay, so you check that root naught is same as the Hadamet plus phase plus Hadamet, both are coming same output or not. Okay, you will get same, right? QC dot root naught. Okay, QC dot root naught. So I am getting? I am getting superposition type of things, right? And you are getting root naught. Okay. Then instead of writing this one, if I write QC Hadam at gate, okay, followed by QC phase of 90. First you run this one, check this one, what is there, then you apply Hadamat. Okay, so it is in 90. Okay, then QC Hadamat get. Okay, both are same. So this is the logic. If you want to do, you can do it. Okay. So when you apply this root, what we are doing? You have seen earlier also, right? When you apply, then we are only operating the 1. We are operating 1. We are not operating with 0. But this operation, root operation, is taking both. Not only it is changing these to superposition state, but also this phase angle or relative phase is also changed. What is the relative phase between these two? What is the relative phase between these two? 90 degree, right? But when you apply 2 times this root, then what will be? It will look like NOT gate. When you apply 2 times, it will be treated as a NOT gate. Okay. Similarly, here I have taken 1. I write 1, right, instead of 0. I apply Hadamat gate. I apply the root NOT gate. Here also you are getting phase angle is what? 90 degree only. Phase angle is 90 degree only. And when you apply root NOT 2 times, you will get your NOT gate. This way, root NOT means
45 degrees rotation. 1 by root 2 value.
45 degree to one particular phase angle, but both phase angles if you calculate it is 90 degree.
1 by root 2 value is
Yes, yes.
it is equal to 45 degrees cycle.
Yeah, can you try this one? So here what happened, I apply Hadamard gate, then I have taken phase angle is minus 90 degree. Minus 90 degree means you will forward in clockwise direction, not in anti-clockwise direction. So again you apply Hadamard gate, it is same as R0. It is not na, minus, that's why it is reversed. It is reversed because minus is there. It is reversibility. Reversibility means what? You will back to your original position, right? So that's why the gate is also written reverse way. Okay, the last part which I want to discuss, because we have less time, that is called as quantum spy hunter program. Anyhow, code is already there in that web interface, you can use it. Try to understand what do you mean by quantum spy hunter. I think all of you have studied cryptography network security. In cryptography network security, who is the sender? Alice is always sender, right? Receiver is Bob, right? In between Alice and Bob, there may be a intruder. Eve, correct, Eve. So this is called as quantum spy hunter. Okay, one side Alice is there, another side Bob is there, and this person Eve is trying to interfere the communication between Alice and Bob. Right, this we know in cryptography, right? So this program is made in such a manner that, okay, it is a long program, I am not going detail about program. So this program is made in such a manner that if Eve is going to do some mischief in between, then it will be known to both Alice and Bob. That's why it is called as quantum spy hunter program. Okay, because you know, see, simple concept is that whatever Alice has made as a superposition, Alice will transfer it to Hadamard gate, means it will change to superposition. So receiver should apply equal Hadamard gate, right, to get this one. And if the receiver is not an intended receiver, receiver don't know that either right, I have written right bit is 0 or the right bit is 1, though then it will not able to find the exact positions, right or not. So even if you interfere in the communication of Alice and Bob, something is going to be changed in the superposition state. So it will only inform the Bob that something is changed. So it will assume that there is some intruder in between in the communication, so it is going to discard it. That's why this program is called as quantum spy hunter program. It is also available in that web interface. Okay, so you can see here, this is the, see here also you can see the meaning of this left to right line. So I have 3 lines. But why I have taken 3 lines? One line is for Alice, another is Bob, another is for the third party. Right? What Alice did, it has taken a qubit, and it write 0. Apply Hadamard gate, then apply read operation. So he says that random bit is now A1. We have a random bit A1. Then it has taken sequential operation, because I have taken only 1 qubit. Alice can take 2 qubit. If 2 qubit, then these 2 operations can done simultaneously. Sometimes I am taking 2 input, A1 is input, A2 is input, I need to configure both. So again I am taking a write operation followed by Hadamard gate followed by the write read, then I am getting random bit A2. Then it is setting a particular value with A1. Suppose I am applying NOT gate. So it is flipping the bit 0 to 1 or 1 to 0. So what it is doing? It is writing, first write the bit QC write, then it is doing NOT gate, then it apply again the Hadamard gate. And this operation is only known to whom? The Bob. what sequence of operation it has to do, the same sequence of operation has to be done in the reverse way by Bob. So, you know, na, encryption is just a reverse of the decryption, right? So, while it is sending the data over a communication channel, so the second line is active. Second line is nothing but a interfere line which Eve able to access. Suppose Eve access this one, Eve will first try Hadamard gate, right? Because it know that if it is in superposition state, first I will try superpositions to make it in a conventional bit. Only if it is present in the conventional bit, I can able to read, right? Then it try to read it. Okay, it try to read it by applying Hadamard operation. Then not only Eve's job is to interfere Alice, it is also need to send the data to whom? Bob. So it start writing by applying a NOT gate and Hadamard, right, and send that information to whom? Bob. When Bob receive this same message, Bob apply first operation is our Hadamard gate, right. So you can see here we are playing with 2 bit A1 and A2. Here Bob has already taken some information which is said, see, no communication is possible if they are not meeting at some condition. Like whenever I am meeting a first person, how I will know that that person is X or Y or Z? Some hints should be there. Like I will tell that the person who is having a 2 pens in the pocket, that is my targeted person, right? That is only said between sender and receiver. So this random bit B2 is generated by the Bob, right? And this interfere bit, it is going to come here. Now assume that you have B2 bit here which you have generated based on the information of Alice, and this information is coming through the channel. So I need to check that these 2 bits need to be equal, right or not? You have some information, based upon that you are generating a bit, and communication channel also whatever message is coming, it should match. Or when you go for hashing function, whenever data is coming, I am checking that hashing value, and based upon my secret key what is my hashing value. If both values are matched, then only I can say it is 1. So when we are checking this B2 and this communication bit A2, this bit is A2. A2 is changed to what? B2. A2 is changed by the spy by B2. So when I am checking this B2 with A2, I have to check that both should match. If they are not matching, that means somebody is interfering in between Alice and Bob. So with the superpositions also you can do this one. The same process is written in the form of code here. It is a long code. How many qubits are required here? 3. So when you have multiple qubit, the line will decide that which operation you need to do first. Sometimes Hadamard gate is applied on all the 3 qubits, right? So but which Hadamard gate is applied first, that you will know based upon the left to right scale. So when you run this code, it is available in that one. You change the program, okay, 2.4, you will find that program. Okay, I have given also here a link. The same thing, only it will open. Okay, you see the same circuit is coming. Okay, so you can try change these values and you can see if there is an interfere, then definitely it is going to identify that there is some bit, somebody is interfering this message in between Alice and Bob. Okay. Similarly, this is the end of the 1 qubit concept. So I am not going for multiple qubit. I will share the slide. Same concept. Instead of 1 bit, we have multiple qubit. All these gates will again repeat. Okay. What do you mean by multiple qubit? Multiple qubit means first qubit may be, let us say 0, second qubit may be 1, or it may be 0, it may be also 0. Okay, it may be 1, it may be 1. Okay, 1 and 0. So this representing my 1 qubit, this I can represent in 1 qubit. Okay. So if I have 1-bit computer system, then I will process one by one. If I have 2-bit system, two things can be done parallelly. Like I am showing you 1125 qubits. That means 1125 tasks can be done parallelly. Madam? Cortex pi it is coming. What you have changed? If you change these variables, you will get Cortex pi. Okay. Yeah. Any question you can ask. You want to create these lines. Same thing is one by one you have to write the line. Is there any?
Any statement or any function, just like clear function.
Oh, clearing the entire thing. You delete the code, it will clear. There is no clear statement.
So, though we give one here, showing two, what does it getting confusion?
No. After one, you have written. You have taken 1 qubit. Then you write 0. Means 0 is filled. Then you applied Hadam at gate. Then you run the program.
Yeah. What does it mean? Showing two circles means?
No, 0 means it is saying that you have written 0. You have not done anything with 1.
For the first step.
First step. And if you remove the last line, as you have written read, you put double slash. Now it is in command line, right? Okay, it is not there.
No, it's not.
Now run. So first I have written 0, right? Hadam at gate means both will be looks like identical in terms of the filling the box, filling the circle. This PPT I will share with madam. So I have said two articles. We are supposed to discuss 2 articles. So these 2 articles shows that how you can apply quantum computing into conventional soft computing approaches. Soft computing means genetic algorithm, particle sum optimization. These are well established algorithms. Just their quantum representation and what is the output. Output input will be same only, right? Only in the process we applied the quantum computing process. So please go through that article. It may take time to understand that each and every step, but the same process we have only applied. Okay. Sir? Yeah, madam.
How can we access quantum resources by using cloud, sir?
You have to pay na for that.
Money, it's not free.
Amazon is providing, but you have to pay for it.
Is there any resources? IBM
Free sources will be there, like IBM also giving, but it is for limit period of time. That is 10 minutes.
per month.
You will not get more time, na. Like cloud resources also, it is for a period of time. Once that period is over, they will charge you. Yeah, I'll say thank you.
We shall break for lunch now.